All right, so for 382, we're going to continue what we were just talking about with linear functions, arithmetic sequences. We're going to apply that to geometric. Geometric sequences are exponential functions that have a domain of consecutive positive integers. 1, 2, 3, 4, 5, blah, blah, blah. Which means, by the way, if you were to try to graph one of these, it would be a discrete graph, which means you're just going to have the dots. Okay, you're just going to plot points. You can't connect them. So, geometric sequences can be represented by formulas, explicit or recursive. We showed those in the last videos. And those formulas can be used to find certain terms or the number of certain values in a sequence. So here's some key concepts. Inside of these key concepts, and worth looking at, is these two right here at the bottom, right? The explicit rule, which is given here, it's a1 times r to the n minus 1, which should be very familiar to what we did in that other lesson that kind of confused a few of y'all about writing the equation with the first term as opposed to writing it with the intercept or the zero term. All right, and then we have the recursive, which is a sub n, which is the previous term, times r. Okay, it's worth mentioning. It's worth writing these down or reading them and making sure you understand them. We're going to go on to the examples here. So, example 1, it says find the constant ratio. Okay, write the explicit formula and find the 7th term for the following geometric sequence. I know some of you are going to just say, well, I've got the first 4, let me just keep going with my pattern. Well, what if I didn't ask you for the 7th term? What if I asked you for the 40th term, right? You would not want to have to do that 40 times. You're going to not have enough time on your test to be able to do that and effectively get the right answer. So what's the quicker way to do it, right? What's the smarter way to do it? All right, so we need to figure out what we're doing here. So the explicit formula says what? It's a sub n equals a sub 1, your first term, times r, which is your base, right? It's the thing you're repeatedly multiplying by. It's the same thing as b in a times b to the x, and then x minus 1. So again, the base formula here for an exponential is what? It's a times b to the x. Well, we're simply doing, remember we also said it could be this. Instead of a, and remember that's a0. So this could be, we can also write it as a1 times b to the x minus 1. We can write it for the first term, right? We can go up by a term here, but we have to subtract up here to account for that. Okay, so they'll stay equal. Now, because I can do this, what you should notice is that that version looks an awful lot like this version. Okay, and it is. It's the first term instead of the 0 term. So it's when x is 1, not when x is 0. So it's not your y-intercept. And up here, we're accounting for that by doing the minus 1 from your x. Okay, and we talked about why that is in the other lesson, how that works. But it applies to this situation because you're specifically given the first term, not the 0 term. All right, so find the 7th term. Well, we got to plug in some stuff first. So a sub n equals a1, which is 3, times r, which I don't know, to the x minus 1 power. So what is the thing that we're multiplying by? Well, how do I figure that out? R, just like last time we did a2 minus a1, we're going to use a2 and a1 again, or a3 and a2, or a4 and a3. But we're going to this time, since we know it's a ratio, we're going to divide them. So a2 divided by a1, or a3 divided by a2, or a4 divided by a3. Basically, any two consecutive numbers in your sequence, you take them and you do this, the later one divided by the first one, the previous one. All right, so I'm going to use the easy ones. I'm going to use a2 and a1. So that would be 1.5 divided by 3. Okay, which may not seem like it does a lot to you or a lot for you here, but what you're going to find pretty nicely is that this works out to be 1/2. Okay, that reduces to 1/2. If you have any questions about why that's 1/2, take and multiply both of those by 2 over 2. Right, so if we did this 1.5 to keep it equal, if we multiplied that by 2 over 2, that would be 3 over 6. And then 3 over 6, I think you all will agree, reduces to 1/2. So this is the rate of change, right? Or not rate of change, I'm sorry, this is the base. So 1/2 is your base. Okay, it's the thing we're repeatedly multiplying by. And you can check that. 1.5 times 1/2 should be 0.75, which it is. 0.75 times 1/2 is, and go on and so forth. So now that I have my explicit formula, I want to, and that would be an n, by the way, since we're using n here. That would be 3 times 1/2 to the 7 minus 1. And again, I did 7 because I'm finding the 7th term. All right, so in your calculator, that means you're doing 1/2 to the 6th power. So a sub 7 equals 3 times 1/2 to the 6th power. Okay, so 1/2 to the 6th power is what? Should be 1/64. So A7 equals 3 times 1/64, which is very simply 3/64. Because remember, that's 3/1. Multiply your numerators, multiply your denominators. So the 7th term in this sequence, right? And if we want to change that to a decimal, that would be 0.046875. Okay? So that's how you use the explicit formula for that. Alright, next one. The 5th term of a geometric sequence is, so I know A5. Alright, the constant ratio is 4. Alright, so they gave me R. Write an explicit formula for the sequence and then find the corresponding exponential function. So A sub n equals A sub 1 times, and then R to the n minus 1 power. Well, I don't know some key information. For example, I don't know A1. But I do know that if I use the 5th term, A5, then that will be A1 times R to the 5 minus 1 power. Well, I know some stuff about that. I know A5 is actually 1792. Still don't know A1. I know that R is 4 because they told me that. And then 5 minus 1, I can go ahead and plug that in as to the 4th. So now what I would need to do is do 4 to the 4th power, which is 256. So 1792 equals A1 times 256. And then divide by 256 on both sides. So that would be 1792 divided by 256, which is 7. So 7 equals A1. So now I know that my formula is A sub n, and I'm bringing this over here, is A1, which is 7, times 4 to the n minus 1 power. Okay? You can put parentheses around the n minus 1, exponent, whatever you want to do. And it says, now write that as an exponential function. So y equals 7 times 4 to the x minus 1 power. And if you wanted to write it in terms of your y-intercept, we could. We would have to go back even further. So that would be 7 divided by 4. So that would be 7/4, right? Times 4 to the x power, right? So this is your first term, your A1. This is A1, and this would be A0. Okay? All right, moving on to the next example. See if we can get it in before my timer cuts out. All right, geometric sequence defined recursively. With A1 being 729, find the first 5, and then write your explicit formula. So we have A sub n equals A sub n minus 1 times negative 1/3. Okay, I wrote it without all the parentheses, but it's the same thing. And again, to do this, you're going to have to know your A1. Okay, so first 5 terms. Basically, if I want A2, because I know A1, then I need to do A1, the previous term, times negative 1/3. So if we do 729 times negative 1/3